Hi guys, welcome to Study with Miss Taylor. Me!
Yay!
So today we're going to be learning about changing standard notation to scientific notation. Standard is a basic word. Anything that's basic means the way it is. So all the numbers that you have seen, that's standard notation. So today we're going to do about scientific notation. And when you talk about scientific notation, there is a formula or a form that we're going to talk about, and it's a times 10 to the n power. This formula has a number, a base 10. We talk about base 10 because that number can be multiplied by 10 or divided by 10. And then the n is the exponent. The exponent can be positive or it can be negative. Some of the things that you have to remember in order to have a scientific notation number is that the A is basically a number 1 or bigger, but it has to be less than 10. Can it be 9.99? Absolutely. Now it also has to be times 10. And the n is the number of spaces. I want to clarify that is the number of spaces and not the number of zeros, which is something that a lot of people get confused about. So scientific notation, what is that? Scientific notation, it's a way to write very small or very large numbers in a short way. Like I said, we have a form, a times 10 to the power of n. So a, we say it has to be a number 1 or bigger, but less than 10. Not a base 1, not a base 100, a base 10. So we're always going to write times 10. And the n is the number of spaces. This is going to be your exponent. We have an example here. We're going to check our rules. The rule says your mantissa, or the number, which is this, 2.3 in this case, that is 2.3. It's bigger than 1, but it's less than 10. So that qualifies. Then we have times 10, which is our base 10, and negative 9. Now what happens with that negative 9? Well, that means that the number is very small. And 5.36 times 10 to the fourth power. So that means that what? Does it meet our requirement? Does the mantissa, or the number, it's 1 or less than 10? Yes, it is. So that qualifies. We put a check on it. Times 10, we have a base 10, and we have an exponent. Now the exponent is positive. The reason why the exponent is positive is because it's a very large number. So we're going to put very large. So these are things that you need to remember. Now let's try, and we're going to convert to scientific notation. The first thing we're going to do is we're going to get our number. This is a standard notation. That means a regular number. And we're going to put a little dot at the end of that. Okay? So the first thing we're going to do is find our mantissa. Our mantissa has to be 1 or bigger, but less than 10. So when we look at this number to the 850 million, and we're going to put a dot right there between the 8.5 because that it meets our requirement. And then we're going to count our spaces from dot to dot. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 spaces. So we have our mantissa to be 8.5 times our base 10 to the power of 8. And we're done. We already wrote it in scientific notation. A positive 8 exponent because it's a very large number. Now we're going to do the same thing again. So I'm going to put a little dot at the end. And I have to find my mantissa. My mantissa has to be between 1 and less than 10. So I think it would be here. That would make it a 2.88. So I'm going to write 2.88 times 10 to the power of how many spaces I have. So I go back to my 2 dots and I count 1, 2, 3, 4, 5, 6. And the number is very big, so my exponent is positive 6. The next one, the same procedure. When I put the dot, we're going to find the mantissa. My mantissa, or my number, is 1.2 times my base 10. And then I count my spaces. My spaces from dot to dot, it's 1, 2, and 3. And this is a positive 3 because it's a large number. We continue to convert these scientific notation numbers. Now, if you notice, it starts with 0 point. That means it's less than 1, so it's a very small number. But we're going to follow the same rule. First, we're going to find our mantissa right there. We already have a dot right here, but we can still mark it. So we're going to count our spaces. We have 1, 2, 3, 4, 5. 5 spaces. We have 4.5 for our mantissa times 10. And it's 5 spaces. However, because this is a very, very small number, that means the exponent is going to be negative. Let's try again. We put our dots. We're going to identify our mantissa. Mantissa is 7.65. It's bigger than 1, but less than 10. Times our base 10. And we count our spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 spaces. But this is a very small number. Therefore, our exponent is negative 10. And then for this one, again, we should feel a little bit more confident now. And we can say from the 2 dots, we have our mantissa to be 6 times 10. And now we have 1, 2, and 3 spaces, but it's very small, so it's negative 3. A big number is anything that it's actually bigger than 1. You can write any number in scientific notation, whether it's small or whether it's big, there is a form. However, we usually use it when we're talking about very, very extremely large numbers, like for instance in here. We have the diameter of a very fine human hair in meters. This is a very, very small number, okay? Now, if we look at the distance from Earth to the moon in meters, we're talking about 385 million meters. So in this case, it's an outstanding number. And instead of keep on writing this number over and over when you're writing a paper or when you're writing something that you have to do it repeated multiple times, then that's when we use scientific notation. And as we did before, the only thing we need is 3 things. We need to have a mantissa, or the number, that has to be between 1 and less than 10. So in this case, we're going to say that this is going to be 3.85. We're going to always, always, always have a base of 10. It's never going to be 1, never going to be 100. It's always 10. And then just the spaces from the dot of the mantissa to the final dot, we're going to count the spaces. The spaces is your exponent. And we have 1, 2, 3, 4, 5, 6, 7, 8. So our exponent is 8 because it's a very large number. We use scientific notation when it's very big or very small, but you can apply scientific notation to any number. It could be 60. We can write that in scientific notation. How do we do that? The same way that we did it before. We go to the mantissa. The mantissa is 6 times 10, and that is what? To the power of just 1. And that you have written 60 in scientific notation. Do we really need to do that? Not really, but you need to know how to do it, right? The diameter of a red blood cell in inches. A blood cell, that is so small, right? So we have here our standard notation. That is the basic number. So now that we feel better, you're going to tell me, what do you think we should find first? The mantissa, the base 10, or the exponent? Yes, the mantissa. Always the mantissa. So our mantissa is just 4. It's a number that is 1 or bigger, but less than 10. Then we have our base 10, which is basically just writing times 10. And then we're going to count the spaces between our 2 points. And that's going to be 1, 2, 3, 4, 5. Our exponent is 5. Now, is this a very big number or a very small number? Yes, it's a very small number. So that means my exponent becomes negative. So this is how we write any number in standard form to scientific notation form. Thank you so much and see you next time.